horizontal velocity of projection is less than critical velocity, then satellite follows parabolic path and returns back on Earth at a point other than point of projection. If VH equal to critical, then performs circular orbit. Third, if VH greater than critical but less than escapes, elliptical orbit. Elliptical orbit. If VH greater than equal to escape, then liberates from gravitational influence of Earth. Write this 4 points. See, that day I had sent some waves and oscillation per question from that Narayana. So I told try till 24. You all have tried till 24? Hello? Hello, can you hear me?
So till 20 I did.
Please try because I have to discuss those sums. They were good sums. Try till 20. I think 24 तक बोला था शायद याद नहीं आ रहा मुझे.
So you settled
27.
Please try it. When you are done, then tell me so that we can start discussion. Everybody should have complete first.
Done, sir.
Critical velocity. See, as the name suggests, critical. तो कभी कभी वो उसको उसका मतलब मैक्सिमम या मिनिमम, उससे ज्यादा कभी कभी नहीं चलता है, कभी कभी उससे कम नहीं चलता है. तो यार उससे कम नहीं चलेगा. उससे कम नहीं चलेगा मतलब किससे कम नहीं चलेगा? विल सी. द मिनिमम horizontal velocity with which a satellite at certain height, the minimum horizontal velocity with which a satellite at certain height must be projected. Minimum horizontal velocity with which a satellite at certain height must be projected so that it revolves in a circular orbit around Earth is called as critical velocity. Now, since the satellite is performing circular motion, so gravitational force of attraction must become centripetal force, then only it will perform circular orbit. So whatever they give answer as, always you have to equate that the force given should provide necessary centripetal force for circular motion. कभी कभी ऐसा बोल देंगे, if force of 1 by r is given, so force is given by 1 by r or r raised to 5 by 2 or anything, but that force must become mv square by r, then only it will perform circular orbit. So gravitational force of attraction must be centripetal force to perform circular motion. Gravitational force of attraction is G mm upon r square. Centripetal force is mv square by r for the body. So I can cancel 1r. So critical velocity formula is gm by r for satellite to perform circular motion around Earth. Copy. Shall I clear?
Yes, sir.
Whenever a body is performing circular motion, always use the force involved must provide centripetal force. For example, if F proportional to 1 upon r raised to 5 is providing centripetal force, then mv square upon r is proportional to 1 upon r raised to 5, etc. Yes, please copy. Completed now?
Yes, sir.
Now I'm trying to find what is the critical velocity for two bodies moving under gravitational influence of each other, then three performing circular motion such that Their circular path performs circumcircle of equilateral triangle. Same way for square. One by one we'll see. First, two bodies performing circular motion due to gravitational influence of each other. So if this is mass m, radius of orbit r, necessary centripetal force is provided by gravitational force of attraction, which is mv square upon r is g mm upon 2r square. 1 m you can cancel. So v square upon r is gm upon 4r square. Therefore v is equals to root of gm upon 4r, which is 1 by 2 root of gm by r, or this. So for two bodies, starting, don't forget, centripetal force is gravitational force of attraction. So if you can manage to remember root of gm by 4r, okay, otherwise you derive in the exam. Second, 3 masses, equal masses performing circular motion in an orbit. Now radius of orbit will be 2/3 of height. Correct? Now why? Because it divides the, this is centroid. Centroid is in the ratio 2:1. So upper part is 2/3, lower part is 1/3. So radius of orbit is 2/3 of height. And height is √3 by 2 into side. That means radius will become s upon √3. So centripetal force is gravitational force of attraction. Centripetal force is m v square by r, but gravitational force at one vertex, because each will be having pull by other 2. It is nothing but √3 times any one force between the two masses. √3 times, which will be m v square by r equals to √3 g, जगह नहीं इधर ऊपर लिखता हूँ कॉर्नर पे, mv square by r is side upon √3 is equals to √3 times g, product of mass and square of distance between them is side square. So 1 m I can cancel from both sides. √3 times v square upon side is √3 gm upon side square. So √3 cancel, ss cancel. V will be root of gm upon side. So Completed?
Yes, sir.
Third one with 4 masses. Maximum they will ask till 4. 4 masses are situated at corner of a square of side A, and they perform circular motion under the gravitational influence of each other. So if these are 4 masses, if you consider any one mass, force acting on these masses will be due to other 3. So force acting on 4 due to 1, 4 due to 3, 4 due to 2. So net force I can say acting will be root 2 times force of 4 due on 1 and force acting on 4 and 2. Because these two are perpendicular, equal, result is root 2 times. So this force will become G into product of mass mm upon distance of side A square. F12 is G, again mm, and distance is root 2 A square. So we can take G m square upon A square common inside root 2 plus 1 upon 2. This is net force. So I can say therefore gravitational force of attraction must become centripetal force. Therefore mv square by r. What will be r here? R will be half of length of diagonal. So it is half of length of diagonal. This is radius of rotation. So g m square upon a square root 2 plus 1 upon 2. 1 m to at least you can cancel. 2 goes up, 2 times v square. Length of diagonal is root 2 into side A equals to gm upon a square root 2 plus 1 by 2. So I can cancel 1a. This will become root 2. So final answer V is equals to gm upon root 2 into root 2 plus 1 upon 2. So if you take root 2 inside, root of all this. Root 2 if I take inside, it will be root of gm, root 2 upon root 2 is 1 plus 1 upon root 2 root. Last time we cannot remember, so don't emphasize on that. You remember only that starting concept. Same thing we had done even in charges. Any doubt in finding resultant force?
No, sir.
Yeah, please then solve. Completed?
Yes, sir.
What is time period of satellite? Time period of satellite? Time taken to complete one revolution around planet. So we can say T is 2 pi r upon critical velocity vc. It is same as 2 pi r upon root of gm by small r. So time period T will become 2 pi r root of r by gm. Therefore T is 2 pi root of r cube upon gm. So T square becomes 4 pi squared into r cube upon gm. That means T square is proportional to r. So you remember as T square equal to 4 pi square upon gm into r cube. Therefore T square proportional r cube. Copy. Or
Yes, sir.
graph of T square versus r cube. T square versus r cube. Since T square is 4 pi square upon gm into r cube. So this if I take along y-axis, this is constant kx. So we can say graph will be straight line with slope equals to 4 pi square upon gm. So it is straight line with slope 4 pi square upon gm. Right. It's also done. If you are doing, then tell fast so that I can complete entire theory. बड़ा chapter है थोड़ा.
Yes, sir. Done.
90% you are getting hint in this synopsis. When you start solving, it will be very simple now. For satellite orbiting close to Earth's surface, small r, which is r plus h, will become approximately r. So I can say t square is 4 pi square upon gm into capital R cube. So t square equals to 4 pi square. Gm is r square g into r cube. R cube and this r square cancel, one r will be left out. So t is 2 pi root of r by g when orbiting close to Earth's surface. Second point, t square is 4 pi square into g, mass is density into volume 4 by 3 pi r cube into r cube. So 4 pi cancel, r cube cancel. This will become 3 pi upon g rho. So t square is proportional to 1 upon rho, or t proportional 1 upon root of rho. Copy these 2 points.
Done, sir.
Gravitational intensity. What is electric intensity? Electric intensity, force upon charge, is called electric intensity. So gravitational intensity will be force upon mass. SI unit is Newton per kg. So if we consider Earth of mass m, small mass m, both are at distance r apart, then gravitational intensity of Earth is force acting on that small mass. So E is G m upon r square divided by m. Therefore E is equals to Gm upon r square. This is formula for gravitational intensity. But if there are n masses situated at origin 1, at distance of 0, 1, 2, 4 and so on, then gravitational intensity net will become G is constant, M is constant, 1 upon 1 square plus 1 upon 2 square dot dot dot. So this will become E is Gm 1 upon 1 plus 1 upon 4 plus 1 upon 16 dot dot dot. So gravitational intensity is Gm into n terms in Gp, where ratio is less than 1. Then directly you can write A upon 1 minus R. That is Gm. A means first term, 1 minus 1 by 4. That will become Gm into 1 upon 3 by 4 equals to 4 by 3 Gm. Copy this to gravitational intensity formula.
Done, sir.
The sum of n terms in GP also written na properly. A upon 1 minus R.
Yes.
Yes, sir.
Gravitational intensity due to ring at a distance x on its axis. Gravitational intensity due to ring at its distance x on its axis is given by E is G m in place of r square at a distance d on the axis. So it is gm upon r square will become d upon r square plus radius distance d square raised to 3 by 2. So if this is ring of radius capital R, then at distance d on its axis, if there is mass situated, then intensity will be Gm due to this Gmd upon R square plus d square raised to 3 by 2. Just write down gravitational intensity due to ring on its axis is Gm in place of R square it is distance d upon R square plus d square raised to 3 by 2.
Done, sir.
Gravitational potential. Amount of work done to move the mass from infinity to a point is called as gravitational potential. Same as electric charge move is called as electric potential. Here it is called gravitational potential. Its SI unit is joule per kg. Don't write volts, it is joule per kg. So if I want gravitational potential in terms of distance, consider body of mass m and small m situated at distance x. So force of attraction between them is G upon x square. If this body is moved by distance dx, then small work done is force into displacement, which will be Gmm upon x square into dx. So total work done to bring it from infinity to any point at distance r will be work done dw by integration. That is equals to G mm upon x square dx का integration. So G mm constant x raised to minus 2 dx. That is G mm x raised to minus 1 upon minus 1 from infinity to r. So this will become G mm upon minus 1 upon x from infinity to r. So minus Gmm 1 upon r minus 1 upon infinity. 1 upon infinity is 0. So minus Gmm upon r. Therefore work done
upon small m is minus Gm upon R. So electric potential is not R square but Gm by R negative. Because you are traveling in the direction of field, we got answer negative. So electric intensity is Gm by R square. This is minus Gm by small r. Write full derivation properly, because from this we are going to get potential energy also.
Done, sir.
On again, if there are n masses, equal masses, situated at 1, 2, 4, 8 dot 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 distances, then net gravitational potential is minus Gm upon 1 by 1, 1 by 2 dot dot dot. So this will become, this was asked in 2013. Therefore, unit mass is situated at 124 dot dot dot. Then what is potential at O? So it is minus G by M, distance 1 by R, 1 by 2, 1 by 4 dot dot dot. That is minus Gm 1 upon 1 minus half. So it will be minus Gm 1 upon half. So it is equals to minus 2Gm. If M is unit mass, you will take 1. So gravitational potential will become minus 2. This was asked in 2013. Just note down this one again. Can I clear?
Yes, sir.
Gravitational intensity and gravitational potential for Earth. First, at any point outside E is G m upon small r square. On surface E is Gm upon capital R square. At any point inside, Earth is a solid sphere. E is Gm into R upon R cube. So inside it is directly proportional to distance, outside inversely proportional. So if we want to draw a graph of E against R gravitational, so it is same like electrostatic this way. Then potential, intensity we got potential. At any point outside, V is minus Gm by small r. On surface, V is minus Gm by capital R. Please copy it in this. Then I'm writing on inside.
Done, sir.
At any point inside. This is if paper is difficult, you have to remember. V equals to minus Gm upon R. This is surface wala formula. Then inside it will become 3 upon 2 1 minute better. Gm upon R, that is at the surface. Then inside 3 by 2 . 3 by 2 minus of small r square upon 2 times r. Just copy this. 2 times r square. 3 by 2 minus r square upon 2 times r square. Almost similar we did even in electrostatics. At the center, at any point inside, minus gm by r, 3 by 2 minus of 2 by r square. Better?
Yes, sir.
Potential energy. Now it is not potential, a potential energy I am writing. Since V is work done to move mass, so minus Gm upon R is work done upon mass. Work done is minus Gmm upon R, that is potential energy is minus Gmm upon R. So formula for potential energy is minus Gm by R. Now favorite question is, if the body from the surface of earth is taken to the height h equal to nr. I have written nr, n can be 1, 2, 3, half, anything. So if height is r, you will take n as 1. Then find increase in potential energy. Increase in potential energy is potential energy at height minus potential energy on surface. So it will take at least 2 days, 5 times. Please practice all the formulas. So many are there. So it is minus gmm upon r plus h minus of minus on the surface gmm by r. So that is nothing but minus gmm r. I have thought h is nr plus gmm upon capital R. So g minus g mm r into 1 plus n plus g mm upon capital R. So this is g mm upon capital R. LCM will be r into 1 plus n. So minus this plus g mm into 1 plus n. So minus g plus gmm upon r into 1 plus n, inside 1 minus 1 plus 1 plus n, minus 1 plus n cancel, 1 cancel, upon capital R. So gm I can write r square g into small m upon r, n upon n plus 1, 1 r cancel, n upon n plus 1 mgr is formula for increasing potential energy when a body is taken from the surface to the height h equal to n upon n plus 1 mgr. Please write 4-5 times as a homework so that it is easy to memorize. N upon n plus 1 mgr. Copy.
Done, sir.
Binding energy. What is binding energy? It is minimum energy with which a satellite must be minimum energy to be given to the satellite externally so that it can liberate itself from gravitational influence of Earth. Minimum energy to be supplied externally. Minimum energy to be supplied externally so that satellite liberates itself from gravitational influence of Earth is called as binding energy. So if I find kinetic energy, potential energy, binding energy is minimum energy required to liberate the satellite. So if I find kinetic energy, potential energy, total energy, opposite will be the binding energy. So see, first for orbiting satellite, what will be kinetic energy for orbiting satellite? Half m critical velocity square. So half m gm by r, that means it is g mm upon 2r. This is kinetic energy. And potential energy is minus g mm by r. So total energy will be kinetic plus potential, that will become g mm upon 2r plus minus g mm upon r. So it will become g mm minus 2 times g mm upon 2r. That will be minus of 1 gmm upon 2r. So binding energy is opposite of total energy. Therefore, it will become plus g mm upon 2r. So binding energy of satellite is plus g mm upon 2r, which is opposite of total energy. Just write this much again.
Done, sir.
Now we can write binding energy. That means kinetic energy, potential energy, total energy, all in terms of binding energy we can write. So sometimes they will give you binding energy and they will ask so many things. One second. Kinetic energy is same as binding energy. Potential energy is minus of twice binding energy. And total energy is opposite of binding energy. Please write this relation. Okay?
Yes, sir.
What is escape velocity? After this we'll start. Then Kepler's law and communication I will explain tomorrow and start with that. Escape velocity, it is minimum velocity with which satellite must be projected from the surface of Earth so that it liberates. So binding energy at surface becomes kinetic energy of projection, then it will liberate. Half, this is G m upon 2 times capital R on the surface. Because it is at rest, this 2 will not come. Equal to half m escape velocity square. 1m cancel. So escape velocity is given by root of 2 times gm by r, which is same as 2 times r square g by r. That is same as root of 2 times r. Copy it in this.
Done, sir.
If velocity of projection is less than escape, then satellite will reach up to height h equal to nr and stop. So for this we'll write n upon n plus 1 mgr equals to half m velocity of projection square and solve the sum to get n if not given. So either sometimes they will ask you height, sometimes they will ask you velocity and height will be given. We'll follow same. If Vp equals to Ve, then escapes. If Vp is greater than Ve, then it emerges out with velocity. Not just emerges, it emerges out with velocity. Therefore, kinetic energy of projection will be kinetic energy of escape plus kinetic energy by which it will emerge. So half m velocity of projection is half m velocity of escape plus half m velocity of emergence square. Throughout half m you can cancel. So we can say velocity of emergence is projection square minus escape square, which is root of projection square minus escape. Copy. So this is 7.8 kilometer per second. This is root 2 times Vc. That means 1.4 Vc. So V is greater than Vc by 41.4%. So only topic left out is what is communication satellite and Kepler's law. Hardly it will take 10 to 15 minutes. We'll start with MCQ and then I will explain you at the end. So tomorrow same time I will complete maximum MCQ of gravitation.